Good afternoon, class. I'm Mr. David Ayoro, teacher of chemistry. Welcome to this lesson. This is a continuation of electrochemistry. In our previous lesson, we talked about how you can predict that a reaction is feasible or not feasible. Today, we want to discuss about the voltaic cells as source of energy. When it comes to voltaic cells, we have got two types of voltaic cells. We have got primary cells and secondary cells. Primary cells are what we call dry cells, e.g. Leclanche cell. These Leclanche cells have got advantages and disadvantages. So the advantages of primary cell is that they are very cheap. Everybody can afford. And they are also convenient to use. The second advantage is that they are portable. You can carry them very easily. The disadvantages are two. One, they are not rechargeable. After you have used them, you throw them away. Also, they cannot produce continuous supply of electricity for a long time. So those are the two disadvantages of primary cell. This is a drawing for the primary cell. This primary cell has got a brass cap, and we have got the sealing material this side. Then inside the brass cap we have got carbon rod, which serves as the positive terminal. The positive terminal is the carbon rod, and in the carbon rod we have got powdered carbon and manganese 5-oxide. The powdered carbon, the reason why the carbon is powdered is to increase the surface area for the positive terminal. So if you are asked in the exam, explain why the carbon must be powdered. This one is to increase the surface area for the positive terminal. And the work of the manganese 4-oxide here is to oxidize the hydrogen produced in this area to water. You know, when hydrogen is not converted to water, they will be produced on the surface of the carbon, thereby rendering this carbon inefficient. So for it not to render this one inefficient, the hydrogen produced next to the carbon rod must be converted to water. Then outside we have got ammonium chloride and zinc chloride paste. The reason why they are in paste form is to carry electric current. You know, electric current can only travel or move from one place to the other when the substance is molten form or in liquid. So there must be in paste form to help them carry electric current from one point to the other. So there are some ionic equations which take place at the terminals. So at the negative terminal, where the zinc case is, so zinc will ionize to zinc ion plus electrons. Then at the positive terminal is the carbon rod. Ammonium ion from the paste will react with two electrons to produce ammonia gas and hydrogen gas. So the two equations are very important. You must know the ionic equation at the negative terminal and also at the positive terminal. So this hydrogen produced will be converted to water, because if you allow the bubbles produced at the carbon, they will make this carbon to be less efficient. So we have to convert them to water. Then ammonia gas produced here form complex salt with zinc chloride in the paste. So ammonia will form a complex salt with zinc chloride in the paste. So a simple dry cell can produce a potential of 1.5 volts. One dry cell. Secondary cell, e.g. lead acid accumulator. Here we have got two components. Here the negative terminal, which is lead paste, and the positive terminal, which is lead 4-oxide. You must know the negative terminal and the positive terminal. The negative terminal is lead paste, positive terminal is the lead 4-oxide. Both the electrons, that is lead paste and lead 4-oxide, are dipped in aqueous solution of sulfuric 6 acid with a relative density of 1.2 to 1.3. So this one serves as an electrolyte, sulfuric acid. So the two electrodes are deep inside there. So the reactions at the electrode when the cell is in use. At the negative terminal is the lead. Lead will dissolve to form lead 2 oxide. So this is the equation for the dissolving of lead paste. That is at the negative terminal. So it dissolves to form lead 2 ion plus the sum electron. At the positive terminal is lead 4 oxide. The hydrogen ion from the acid, will combine with the 2 electrons produced at the negative terminal to produce lead ion and water. So this is the equation for the formation, or this is the equation for the reaction at the positive terminal. Lead 4 oxide reacts with hydrogen ion from sulfuric acid plus the 2 electrons produced by the lead to form lead 2 ion and water. That is to say, lead 4 ions react with hydrogen ions from the dilute sulfuric acid to produce lead 2 ions and water. So LB, this lead 2 ion produced at the positive terminal and at the negative terminal will combine with the hydrogen sulfate ion from sulfuric acid to form lead 2 sulfate. You know, lead 2 sulfate is an insoluble. So this one is insoluble and it adheres to the electrons. It will prevent the flow of electron from one electron to the other. This lead 2 sulfate. So the equation for the discharge, this is when the cell is in use. Lead paste, that's negative terminal, and lead 4 oxide, positive terminal, will react with hydrogen ion from sulfuric acid and sulfate ion from sulfuric acid to form lead 2 sulfate and water. So this is the equation for the discharge of the cell. If you are asked to write the equation for the discharge of the cell, you write this chemical equation. Lead 4 oxide plus hydrogen ion, 4 hydrogen ion plus 2 sulfate ion, giving us lead 2 sulfate, which is a solid, plus water. So lead 2 sulfate form here should not be left for too long, since the fine lead 2 sulfate will change to coarse, non-reversible and inactive form, hence the accumulator will become less efficient. So you should not leave your cell for a longer time before you discharge it, before you recharge it, because this is the equation for the discharge. So as the battery discharges, lead and lead 4 oxide are depleted. You know, they are depleted because they are being converted to lead 2 sulfate and water. So they are depleted and the concentration of the acid also decreases. This acid, the concentration will decrease. Hence, it is better for you to increase the concentration during the time when you are recharging the cell. So this is the equation for the recharging. The equation for the recharging is the reverse of this one. Because when you are recharging, you want to restore back lead paste and lead 4 oxide plus the acid which had been used up. So lead 2 sulfate plus water being recharged to produce lead, which is the negative terminal, lead 4 oxide, which is the positive terminal, plus the acids. So this, if you are asked to write the equation for the recharge, this is the equation for the recharge. All the car batteries are composed of 6 lead acid cells connected in series, giving a potential of 12 volts. So the cells are connected in series. If you look at the wet cell, they're connected in series. Each and every cell produces, in total, each and every cell contains 2 volts. So in total, they will produce 12 volts. This is the recharge and the discharge of the wet cell. In our next lesson, we are going to discuss now electrolysis, that is the self discharge of ions and the electron. Thank you.